presumably man's spirit, should be elevated if he can better review his shady past and analyze more completely and objectively his present problems. He has built a civilization so complex that he needs to mechanize his records more fully if he is to push his experiment to its logical conclusion and not merely become bogged down partway there by overtaxing his limited memory.
The history of every great invention is based on a lot of prehistory. In the case of the World Wide Web, there are two lines to be traced: the development of hypertext, or the computer-aided reading of electronic documents, and the development of the Internet protocols, which made the global network possible. World War II provided much of the motivation and funding to produce the programmable calculating machines for everything from calculating artillery firing tables to cracking the enemy's secret codes. The perfection and commercial production of vacuum tubes provided the fast-switching mechanisms these computers needed to be useful. The Colossus machines were early computing devices used by British codebreakers to read encrypted German messages. They were the early electronic computers. ENIAC was thought to have been the first electronic computer designed to be Turing-complete, capable of being reprogrammed by rewiring to resolve a full range of computing problems. It was preceded in 1941 by the fully taped programmable C3, the world's first general-purpose electromechanical computer designed by German Konrad Zuse. The C3 used relays for all functions, unlike the ENIAC and Colossus machine, which used vacuums. Even though using computers still requiring flippant switches and punch cards, their size became much smaller. In the early 70s, a 1/8 by 1/6 inch baby chip containing 2,300 MOS transistors had been created and was believed to have been as powerful as the ENIAC. The transistor was an influential invention that changed the course of history for computers, surpassing the previous generation of vacuum tubes. Since then, we have passed through the generation of integrated circuits into the generation of microprocessors. Through the decades, a number of people were responsible for developing today's global network. Amongst them are Vannevar Bush, Douglas Engelbart, Ted Nelson, Vint Cerf, and Tim Berners-Lee, who contributed to the worlds of computing and the Internet. Vannevar Bush was the chief scientist advisor to President Roosevelt and the director of the government's Office of Scientific Research and Development during World War II, where he supervised the research that led to the creation of the atomic bomb and other military technologies.
The new weapon blasted the enemy completely out of the war. Japan no longer had the will to fight.
His contribution to the evolution of computers started with the invention of the differential analyzer in 1930, one of the first automatic electronic computers. His concept of the MEMIX was the prototypical hypermedia machine, which was a device based on microfilm for storing vast amounts of documents on a computer desk. Bush envisioned two touchscreen graphical displays, a keyboard, with a scanner attached, allowing the user to access all knowledge using connections very similar to what we now know as hyperlinks, although he never used the word.
The resemblances between the brain's operations and the operations of a modern analytical machine is a fascinating aspect of it.
Early December 1950, I was driving to work one Monday and thinking rather deeply. Gee, I had just gotten engaged. The day before she had said yes. And so my head was full of all the great things that were going to be happening. But then I realized I was, relatively close to my place of work, and I better turn my attention to what my work should be. A very clear sort of sentence came out. Why don't I try to make a career that maximizes its contribution to mankind? I'll never know where that came from. But anyway, I thought, aha, boy, that sounds like a good, glorious goal.
16 years after Vannevar Bush published his article, Engelbart published his own version of Bush's concept, describing an advanced electronic information system in the paper Augmenting Human Intellect, a Conceptual Framework. In 1968, the Fall Joint Computer Conference in San Francisco influenced the development of the first personal computer, where Engelbart made the first public appearance of the mouse, Windows, word processing, email, hypermedia with object linking and addressing, and video teleconferencing.
I hope you'll go along with this rather unusual setting and the fact that I remain seated when I get introduced, and the fact that I'm going to come to you mostly through this medium here for the rest of the show. And I should tell you that I'm backed up by quite a staff of people between here and Menlo Park, where Stanford Research is located, some 30 miles south of here. And if every one of us does our job well, it'll all go very interesting, I think. The research program that I'm going to describe to you is quickly characterizable by saying, if in your office you as an intellectual worker were supplied with a computer display backed up by a computer that was alive for you all day and was instantly responsive, instantly responsive to every action you had, how much value could you derive from that? Well, this basically characterizes what we've been pursuing for many years in what we call the augmented human intellect. Okay, to talk about control devices, we'll use this overhead camera shot where you can see the devices that I'm using. I use 3, and they're not all standard. We have a pointing device called our mouse, a standard keyboard, and a special key set we have here. And we're going to go for a picture down in our laboratory in Menlo Park and pipe it up. That'll show you from another point of view more about how that mouse works. Come in, Menlo Park. Okay, there's Don Andrews' hand in Menlo Park. And in a second we'll see the screen that he's working and the way the tracking spot moves in conjunction with movements of that mouse. I don't know why we call it a mouse. Sometimes I apologize. It started that way and we never did change it. Now the keyboard in the middle is essentially a standard typewriter keyboard except for a few special keys out on the side. The computer knows it instantly when you hit one and makes an appropriate response. This device over here is unique to us, and we always have to justify and explain it. We'll do it in reverse order. We'll explain it first. It provides for you the one-hand equivalent of what you can do with a keyboard. There are 5 keys, and normally each finger sits on a key, and depressing any one key at a time produces a character. And any 2 keys at a time also. And in fact, any combination of depressing, of which there are 31 combinations.
In 1970, at Xerox PARC, he introduced the Windows graphical user interface, which was used later by Steve Jobs for Apple computers. Engelbert's theories about the power of collective knowledge via real-time electronic media have also led to other forms of many human-computer interactions, including such collective online activities as virtual communities and online forums. During the same period, Ted Nelson, who coined the term hypertext, which he defined as a non-sequential writing or non-linear text system, first described in a Vassar College newspaper in 1965. Nelson was particularly concerned with the complex nature of the creative impulse. He saw the computer as a tool that would make explicit the interdependence of ideas, drawing out connections between literature, art, music, and science. As he put it, everything is deeply intertwined. His vision for a new form of interactive literature was a fusion of Bush's notion of a memory bank, which was organized around associative links of Engelbert's research in human-computer interface and the augmentation of human intellect. Nelson has continued to develop his theory in Project Xanadu, a high-performance hypertext system that assures the identity of references to objects and solves the problems of configuration management and copyright control.
The name of the project I've been working on for 42 years now, working toward this particular model of what I think is the deepest form of possible literature. And it's gone through about 20 or 30 designs, depending on what you count. So Xanadu has been a goal and a way of thinking about a new medium, especially in which everything is permitted for requotation. The problems everyone has been encountering now with copyright were exactly what we foresaw. You see, the problem is, in the Xanadu project, it was clear from the very first, to me at least, that we had a simultaneous issue of writing, keeping track of versions, allowing quotation, and copyright and links. All of those problems to be solved simultaneously. And the Xanadu designs have all solved them simultaneously, I think most deeply in the recent designs. And so, promoting that now against the World Wide Web, which is a preposterously simple design that puts everything in lump files, scrambles the text with stupid encoding gewgaws, and allows links only in one direction and links which do not overlap. This is a corrupt and decadent structure which must be replaced, but it's very hard to replace because it is so deeply built into today's internet software.
The Xanadu system would enable artists to post their work in electronic form, letting them be accessed any number of times and making it available to everyone. Vince Cerf, another great contributor, was involved in the early design of the Internet protocols and was present in August 1969 when BBN delivered the first IMP to UCLA. The first ARPANET link was established on November 21, 1969, between the IMP at UCLA and the IMP at SRI. In May 1974, Cerf and Bob Kahn created a new protocol they called the Transmission Control Protocol. TCP allowed networks to be joined into a network of networks, or what we call the Internet. Cerf and several of his colleagues at ARPA made a major refinement in 1978. They split TCP into two parts. The new protocol was called TCP/IP, which went on to become the standard for all Internet communication. Vince Cerf is called the father of the Internet. He earned a nickname as one of the co-authors of TCP/IP, the protocol that allowed ARPA to connect various independent networks together to form one large network of networks, or the Internet.
What's it like to see 30 years ahead of your time? And the answer in part is a tremendous challenge because no one can see what you're seeing. I wouldn't claim to have seen as far as that. My work has been much more concrete. A problem was posed and a solution was found, and it had implications that we didn't necessarily fully appreciate, but we kept working the problem. And then we built it, and then we got other people involved in it, and it just kept growing. But that's been an evolution. And I think in many ways, Doug's thinking was more complete in some sense. I mean, the implications of his ideas were in his own head anyway, I think, were far more complete about things you could possibly do if you were to design and build an information infrastructure that helped knowledge workers do their work. And it's not what he built, but I think it was very much in the spirit of what he saw. I don't know that he fully thought about what it would be like if there could be hundreds of millions of machines all interacting with each other, and that wasn't feasible in the days when he was building things on $6 million computers. None of us foresaw any of that because I don't think anyone, except maybe the guys at Xerox PARC, saw the possibility of personal computing and built them in 1972. 20 to 30 years before, well, 20 years anyway, before PCs were really feasible. Then they spent $50,000 per machine, and no one in his right mind would spend that unless you were truly trying to explore the future, which PARC reasonably was trying to do.
Nelson's vision of an ideal new publishing system for the digital age was eclipsed by Tim Berners-Lee's invention of the World Wide Web in 1989, when he proposed a network hypertext system for European Particle Physics Laboratory, CERN, in Switzerland. Berners-Lee completed the first web browser and server software in late 1990, began distributing it by the following year. He also addresses the potential to incorporate sound and image. From start, Tim Berners-Lee saw the web's embrace of multimedia, which could well provide to be its enduring legacy. By 1993, the system was adapted for Mac and PC by Mark Anderson and a group of graduate students at the University of Illinois, calling their version of the browser Mosaic. Widely distributed on the internet, that browser made the start of the World Wide Web truly worldwide. Later, Netscape took over as the first commercialized browser.
We are both excited about the future and what can be done, so we just talked about the future of portable computing devices that within the next 10 years will really begin to augment our ability to communicate with people around the world. That revolution is, as you know, is just beginning. Still a very small fraction of the population is connected together on the internet, and the internet's still not robust, it's not safe, you can't find things on it, it's hard to navigate still, and over time all those problems will be solved. So we're excited about that. And again, Doug's philosophy about how to work to make advances in that, I think, becomes more relevant over time, not less.